Rounding rule. 5 or more, let it soar. 4 or less, let it rest. What that means is if you're rounding and the number is 5, 6, 7, 8, or 9, then you round up to the next number. And if it's 4 or less, so if it's 4, 3, 2, 1, or 0, then it rests. It just stays the same. It doesn't go down to the previous number. It just stays the same. This is a really handy rule to learn off for rounding. Example 1, round 0.3749 to 1 decimal place. So we start by writing out the number 0.3749. The next thing we're going to do is decide what is the rounding digit. So since we're trying to round to 1 decimal place, then the first decimal place becomes the rounding digit. And the first decimal place is 3. So we circle 3 and we label it RD. RD stands for rounding digit. So this is the digit that we will round off. So this number will either increase to 4 or it will stay the same. So the rule is 5 or more, let it soar. 4 or less, let it rest. So the number that tells us what to do is the number after it. And the number after it is the number 7. So we call this the telling digit. So we underline the number 7 and we turn that into a capital T. So capital T stands for telling digit. The telling digit tells the rounding digit what to do. So it's the rounding digit that may or may not change depending on what the telling digit is. So 5 or more, let it soar. 4 or less, let it rest. So we're focusing in on the 7. So the 7 is more than 5. So we're going to put an upwards arrow below the 3. And the 3 is going to round up to 4. So 5 or more, let it soar. So the 7 is more than 5. So the 3 soars up to 4. And then we have to fill in the rest. So since the original number was 0.3749, it wouldn't make sense to say it rounds off to 4 because 0.3 and 4 are very different. So we're going to have to fill in front of the 4, the decimal point and the 0. And we also put in our squiggly equals sign to say approximately equal to. So 0.3749 is approximately equal to 0.4, which is rounded to 1 decimal place. And this makes sense. And you should always think about maths and think back and see, does your answer make sense? 0.3749 is very close to 0.4. So that makes sense mathematically. Example 2. So we have the same number again, 0.3749. This time we want to round to 2 decimal places. So again, we start by writing the number. If we're interested in 2 decimal places, then we circle the second decimal place, which is 7. So 7 is our rounding digit. And then the number straight after the rounding digit is the telling digit. So the telling digit is 4. So the 4 will tell the 7 what to do. So the 7 will either go up to 8 or it will stay the same. It will rest on 7. So we focus in on the 4. The 4 is going to tell us what to do. That's why it's called the telling digit. So 5 or more, let it soar. 4 or less, let it rest. So 4 or less, let it rest. So the 7 will rest on 7. So we have an arrow down to show the 7 is going to rest, and we have the number 7. Now we're not finished because it wouldn't make sense to say 0.3749 rounds off to 7. That wouldn't make sense mathematically because those numbers are not similar. So we have to add in front of the 7, the 3, the decimal, and the 0. And then we have our squiggly equal sign to say 0.3749 is approximately equal to 0.37, and 0.37 is indeed 2 decimal places, and that's what we wanted. So again, check, does your number make sense mathematically? Example 3, round 0.3479 to 3 decimal places this time. So again, we write out the number. If we are interested in 3 decimal places, we're going to circle the third decimal place, which is 4. So 4 becomes the rounding digit. So 4 will either round up to 5 or it will rest on 4. The number directly after the rounding digit is the telling digit. So the 9 is the telling digit, and the 9 will tell the 4 what to do. So we focus in on the 9. So we say our phrase again: 5 or more, let it soar. 4 or less, let it rest. So it's 5 or more. So the 4 is going to soar up to 5. So we have the upwards arrow and the 5. Now we're not finished, because it doesn't make sense to say 0.3749 rounds off to 5. That doesn't make sense mathematically. Those numbers are not close together. So we have to add in all the units and all the decimals in front of the 5. So we have approximately equal to 0.375. So we were asked to round to 3 decimal places, and our answer is 3 decimal places. And it makes sense mathematically because 0.3749 is very close to 0.375. So it makes sense mathematically. Example 4, we're going to round the same number to the nearest whole unit. So again, we write the number 0.3749. If we're interested in the nearest whole unit, then we circle the first whole unit, which is 0. So 0 is our rounding digit. So this is either going to round up to 1 or rest on 0. The number directly after the rounding digit is our telling digit. So 3 is our telling digit, and our telling digit 3 will tell the 0 what to do. So focusing in on 3, the rule is 5 or more, let it soar. 4 or less, let it rest. And since 3 is less than 4, the 0 is going to rest on 0. So 0.3749 rounded off to the nearest whole unit is 0. Example 5, we want to round the same number again to one significant figure. So we write out the number again. We circle the first significant figure. It also happens to be the first decimal place. This is a coincidence. The rule is not that you necessarily circle the first decimal place. You circle the first significant figure. And a significant figure is a number that is not 0, so a non-zero digit. So in this case, the first decimal place and the first significant figure happens to be the same number. So we circle 3, this is the rounding digit. And then the number directly after it is the telling digit. So the 7 is going to tell the 3 what to do. 5 or more, let it soar. 4 or less, let it rest. So the 7 is 5 or more. So the 3 is going to round up to 4. Now we're not finished, because it doesn't make sense mathematically to say 0.3749 is approximately 4. They're not close together. So we have to add in the decimal and the 0. So we get approximately equal to 0.4. So our answer has one significant figure in it, one non-zero digit. Example 6, round 37.49 to one significant figure. So we write out the number 37.49. And since we're interested in one significant figure, we circle the first significant figure. So we circle the first non-zero digit, which is 3. So 3 is our rounding digit. So the first SF, the first significant figure, is the rounding digit. So the number directly after it is the telling digit. So the 7 will tell the 3 what to do. So focusing in on the 7, 5 or more, let it soar. 4 or less, let it rest. So we're going to go with 5 or more. So 3 is going to soar up to 4. Now we're not finished, because it doesn't make sense mathematically to say 37.49 is approximately equal to 4. That does not make sense mathematically. So what we have to do is replace this 7 with a 0. So now our answer is approximately equal to 40. And this makes sense mathematically. 37.49 is approximately equal to 40. And the number 40 has only one significant figure in it. So one non-zero digit. Example 7. Round 6,745 to one significant figure. We write out the number, and then we circle the first significant figure. So in this case, the first significant figure is 6. 6 is the first non-zero digit. So the number directly after the rounding digit is 7, so that's going to be our telling digit. So the 7 will tell the 6 what to do. So 5 or more, let it soar. 4 or less, let it rest. So we're going to go with 5 or more. 7 is definitely more than 5. So the 6 is going to round up to 7. So we're not finished because it doesn't make sense mathematically to say 6,745 is approximately equal to 7. That doesn't make sense mathematically. So we have to replace each of these digits with zeros. So we have approximately 7,000. And this makes sense mathematically. 6,745 is quite close to 7,000. And our answer has only one significant figure, so one non-zero digit. Example 8, round 6,745 to two significant figures. So again, we start with our number 6745. Since we're interested in two significant figures, we circle the second significant figure, which is 7. This is the rounding digit. So the number after it is the telling digit. So we focus in on the 4. The 4 is going to tell us what to do. So 5 or more, let it soar. 4 or less, let it rest. So we're going to go with 4 or less. So the 7 is going to rest on 7. So we're not finished because it doesn't make sense mathematically to say 6,745 is approximately equal to 7. So what we have to do is bring down the 6, and that will give us two significant figures, and then change the 4 and the 5 to zeros. So we bring down the 6, and then we change the 4 and the 5 to zeros. So 6,745 is indeed approximately equal to 6,700. They are very close. It makes sense mathematically. And our answer has two significant figures in it, so two non-zero digits. So our answer is 6,700. Round 6,445 to three significant figures. So again, we start by writing out the number. So we have 6,745. Since we're interested in three significant figures, we circle the third significant figure, which is 4. So the third SF, or the third significant figure, is the rounding digit. So the number directly after the rounding digit is the telling digit. So that's the 5. So the 5 is going to tell the 4 what to do. So we focus on our rule again. 5 or more, let it soar. 4 or less, let it rest. So 5 is 5 or more, which means that the 4 is going to round up to 5. But we're not finished because it doesn't make sense mathematically to say 6,745 is approximately equal to 5. That does not make any sense mathematically. So what we have to do is bring down the 6, bring down the 7, and then we change the number at the end to 0. And so we have approximately equal to 6,750. And that makes sense because 6,745 is very close to 6,750. And our final answer has three significant figures, which is what we wanted. So that's three non-zero digits.